I'm afraid you're giving them ideas a bit too late.
Hi guys. We are known as scientists. The aim of this is it's an egg drop challenge. It's a basic challenge of physics where basically you have to drop an egg from a certain distance and stop it from cracking or breaking in any sort of form. And you can use anything to use it. We didn't have rules about this, even though we didn't have rules about it, so we just used a basic principle called layering, and we used styrofoam balls in order to in the wrapping in order to suck up the force that is exerted when the egg falls onto the ground. And what the styrofoam does, it absorbs the compression force that the egg will exert in order to crack or absorb some of it. And the layering that we did with the newspaper and the cloth that we did, that will also absorb some of the force that would be exerted from this. Look like a bunch of
what we also tried, sir, was well, as you will see, most of the other groups use quite a bit of materials. What we tried to do was make everything as light as possible, so that when it falls, it will fall a bit slower than the others. But what we also tried to do was make it secure as well as light, so then when it falls, there's less weight on it, so that it might fall a bit slower.
Hi guys, so we took our egg, put it in a glove with styrofoam balls in. Then we put the glove in another glove with styrofoam balls. Then we put in 2 foam cups with duct tape around, and we wrapped it with newspaper. And then we put more styrofoam balls in a plastic bag with the cup in, and we wrapped it with string.
So this is 0.1 kilograms, and the reason we try to make it so light is because a lighter object will fall slower and it will have less impact once it touches the ground.
For example, if it takes longer to reach the ground than something that will weigh more. The styrofoam balls also act as a cushioning to keep the structure of the egg intact.
To protect the egg, we took our egg and used the hot glue gun to glue styrofoam balls on top of the egg, and we layered it like twice, I think. And then we took that full styrofoam cups and put the egg inside there and duct taped it closed. After that, we wrapped it twice in newspaper, glued that together, and put it in a plastic bag and put bubble wrap around it.
And how much does it weigh? Because yours is very light.
I think it's the lightest. It's 0.08 grams.
0.08 kilogram.
Yeah,
Sure. Sign 80 grams.
Increasing the amount of time the deceleration takes place will decrease the amount of force the object will feel, which is why surrounding the egg in layers of elastic material can increase the amount of time it takes for the egg to slow down and hit the ground.
Now you see, the reason we surrounded it with so much elastic material, styrofoam, we just covered it with a lot of styrofoam, is because if you look at this formula here, increasing the amount of elastic material also increases the change in time, which in turn will decrease the force that the egg experiences once it hits the ground.
Thanks, sir.
Speak louder.
Good day, everybody. As you can see, our product is in a box. So we have covered our egg in styrofoam balls, styrofoam cup, and few layers of newspaper and a plastic bag in a box. Okay, so this object, what we're starting with is referred to as vertical projectile motions. And we are going to explain what's going to happen, like how we put that to protect the egg so it doesn't crack.
the velocity decreases or changes, but the gravitational force constant acting downwards.
So the mass of this thing is 0.16 kilograms. So our hypothesis is the lighter the object and the higher its surface area, the more it will be slowed down by air resistance. So now I'm going to say.
So what we did here was we took 2 styrofoam cups and we added styrofoam balls inside with the egg so that it's cushioned, and then because there's still more space in the styrofoam cups, we added newspaper so that there's no movement of the egg when it drops. And then we layered it with the newspaper to add cushioning to lessen the impact.
Okay, hello everybody, this is what I built for my egg. I built this parachute to reduce the momentum. I hope it slows down the egg a little bit. And this is where the egg is inside. The egg is in the middle of the sack, and it's in 2 styrofoam cups filled with styrofoam balls. So to make sure that there are no sharp objects around the egg, and around this there are many balls of newspaper to reduce the force, and I hope the egg will not break.
Right, all, here's my one. It's got a parachute, it's got a milk carton, and inside is an egg, which I slit the bottle, and I just glued a piece of styrofoam to the egg so the egg floats. And now I fill it with water. So mine's going to weigh the most, but the egg's floating on top. And when it hits the bottom, boom.
The bottle breaks.
If the bottle doesn't break, which I thought of when I put some tape around it, the egg is going to take a long time to go through the friction of the water to hit the bottom. But that's why I need the parachute, because if it hits sideways, it's not going to have any distance to go. So it's got to float on top and hit the bottom. There we go.
Okay, Pascal.
That's cool.
Oh, whoa.
Let's let go.
Okay. Okay, someone grab it. Grab it. Who's next? Wait.
What?
Okay, just hang on a moment.
Even like
Yo.
This will never be.
Okay, next group.
I'm waiting for you to come out.
I don't know. I was just the same.
Wow. Thank you. See.
I didn't look at all
There we go. I mean, the I just need to say
egg is fine, guys. Okay,
That's what cracks him over.
Can we know if your egg is fine? Can we see your egg? Okay, there we go. Your egg is fine.
Mine might be the only one that fails. Let's not.
Yes, sir,
not.
I'm wrapping it also. Yes,
Yeah, it's perfect. It's perfect.
Yours just floated down. Did you see that?
Everyone here use your phone cup. It doesn't
Oh, well, you can give me all the eggs back. I'll have them for breakfast tomorrow. Thank you.
It's my lunch, sir.
No, we didn't.
Bye.